This is the Geosphere
by Hunter Hyde,
Shadiana Heyman,
Candace Kerr,
and Alexis Garcia. This is the geosphere. The geosphere consists of all Earth's inner layer, which includes the crust, which is the green part, the lithosphere, which is the yellow, the asthenosphere, which is the orange, the upper mantle, which is the red, the transition layer, which is the yellow, the lower mantle, which is the red, the double prime, which is the black, then the outer core, which is the orange, and the inner core, which is the blue.
Okay, so the outermost layer of the Earth is the crust, and it floats kind of on top of the mantle. And it's pretty thin. It's only about 1% of the Earth's mass, and it's only 25 miles deep. And the temperatures on the crust vary depending on where you're at and like how deep it goes and how high it goes. So the crust is composed of many different rocks and minerals, and it's broken into several different plates, and these plates are either oceanic plates or continental plates. The oceanic plates are only like 5 to 10 kilometers below the ocean floor, and they create mid-ocean ridges, which is either where like they come together or they come apart, creating either valleys or mountains. And both the oceanic and continental plates consist of convergent and divergent boundaries. Landforms are a part of the crust terrain, and there are two types of landforms, major and minor. And the major landforms are mountains, hills, plateaus, and plains, and the minor landforms are buttes, canyons, valleys, and basins. And landforms are caused by plate movements and erosion, and so practically how minor landforms are formed is whenever the plates come apart, and major landforms are formed whenever they come together. On the crust, we have a process called the rock cycle, and this consists of 3 types of rocks called igneous rocks, sedimentary rocks, and metamorphic rocks. And the igneous rocks are the most abundant of the 3, and they are made whenever magma cools and makes crystals. And these crystals are then eroded by wind and water and carried to other places. And then they're buried underground, making sedimentary rocks whenever it like the pressure from the ground kind of bakes them, I guess. And these, whenever they get baked, they make crystals, and these crystals are called metamorphic rocks. And they get eroded too, and sometimes they're sent underground or to the water, and it just like goes to the igneous rock again, and it just kind of repeats itself over and over again.
Next layer is the lithosphere, and it's right below the crust, and it is the top part of the mantle, and it's the richest part of the Earth. It is made of elastic material, but not plasticky, and it makes tectonic plates, and it's 200 kilometers deep below the Earth. The asthenosphere is next. It is 200 to 700 kilometers below the Earth's surface. It is a plastic-like consistency, and there is convection in it, which causes tectonic plate movement. Next is the mantle, and it's between the crust and the core. It is 2,900 miles thick. It is 1,832 degrees Fahrenheit, and the closer you are, to the core, the hotter it gets, and it is made of 4 sections, which are the upper mantle, transition layer, the lower mantle, and double prime layer. The section of the mantle is 21.5 silicon, 44.8 oxygen, 22.8 magnesium. It is also made of iron, aluminum, calcium, sodium, and potassium, which form silicate rocks in the mantle. The upper mantle is malleable and it has sublayers, which include the lithosphere and asthenosphere. The transition layer is actually where rocks get really dense, but it prevents convection and moving the large exchange of mass. The lower mantle is just hotter and denser, and then the double prime layer is like a razor thin layer preventing exchange from the lower mantle and the outer core.
So the next layer is the outer core, and it's kind of magma-like, and its composition is like mostly nickel and iron with a little rock in there. It's caused by the heat from the inner core, so that's why it's a little more liquid than the mantle. And that creates the magnetic field because of all the convection that goes on. And the convection is caused by the heat trying to escape outside of the core. So the outer core is around 4,000 to 5,000 degrees Celsius. It's 2,200 kilometers thick, and it's the second largest layer of the whole Earth. And it's where most of our precious metals are located because they were more dense, so they got dissolved in the iron and stayed down in the outer core. And that's why most 90% of the Earth's sulfur is in the outer core, and that makes the outer core lighter, and it's not as heavy as scientists thought it would be.
Okay, so after that is the inner core, and it's believed to be solid, and it's the innermost layer of the Earth, and it's made of iron and nickel alloy components, and it's also 5,700 Kelvin degrees, so it's pretty hot. And then it's also made of light elements such as silicon, oxygen, and sulfur. And then it's believed to be gradually growing. The inner core was once believed to be liquid, but we now know that it's solid. And in 1936, seismologist Ian Gleeman proved that it was actually really solid. And the heat that's in the inner core is caused by 3 things, and the 3 things are Earth's gravitational pull between the moon and the Earth, and residual heat that is formed, or that is there from when the Earth formed, and it's also caused by radioactive decay. And there are elements in the inner core that can dissolve iron, and those elements are cobalt, gold, and platinum. And then some scientists also believe that within the inner core itself, there's also another inner core, but that has yet to be proven. In addition to all the information we just told you, here are some interesting facts about our geosphere.
Interesting fact number 1. Just 11 elements make up 99% of the Earth's crust. These consist of oxygen, silicon, aluminum, iron, calcium, sodium, potassium, magnesium, titanium, hydrogen, and phosphorus.
All parts of the geosphere, including the crust, lithosphere, asthenosphere, upper mantle, transition layer, lower mantle, double prime, outer core, and inner core, all contain the element silicon. I hope you liked our presentation of the geosphere. We'll talk to you next time. Bye!
Bye.
Bye. Bye.